Here are the answers to that free response quiz. Number 1, sketch a picture of a graduated cylinder capable of measuring 15.45 milliliters of water. Now, you didn't have to show the entire cylinder, it was just a portion, but the key is that we should be able to measure every tenth of a milliliter, so the markings should be every tenth of a milliliter, and then I can estimate the hundredth, so there should be a line somewhere for 14.4 or 15.4 milliliters, so that then I can estimate the 0.45. So any portion of a graduated cylinder marked off to the nearest tenth of a milliliter gets you a point. Number 2, a metal sinker with a mass of 20.44 grams was added to the graduated cylinder mentioned above. The final volume is 21.50 milliliters. Calculate the density of the metal cylinder. So we first have to find the volume of the sinker, and so we'll just subtract final and initial volume to get the volume of the sinker. If the first cylinder had 15.44 milliliters of water and the final volume with the metal piece was about 21.50, the difference is 6.05, and that would have been the volume of the metal piece. Now, FYI, moving forward, when they give you something like 21.50, the 0 is important. That it means, obviously in this case, that the graduated cylinder was marked every tenth of a milliliter, and we can estimate the hundredths, and sometimes we estimate that it's right on the line, but often people get kind of lazy when they do free response, and they just write the number as 21.5, who cares about the 0? But actually, to show that we're subtracting and reporting our answer properly, we want to show that both of those measurements had 2 decimal spots. And so then when I subtract, I can still leave 2. So same thing, if they would have given me 21.50 and I were doing a multiplication or division or something, then that counts as 4 sig figs. If I just get lazy and drop the 0, now it's 3, and that's not the same measurement. So when your AP test gives you like a 0.0 or something, leave the zeros. It's important to how we can round our final answer. Now I can just do density is mass over volume. And so my density is somewhere around 3.38. My mass has, 4 sig figs, and my volume of the sinker alone only has 3. Then the last two, number 3. So this metal cylinder, sinker, was added to a graduated cylinder with water, and sometimes people get a little excited and they splash the metal piece in the water, and some of the water kind of splatters out. And so we want to know, how would this error cause the density to be different? Would it be too high, too low? And so here's kind of my explanation of it. If some of the water splashes out, it's going to seem as though the volume of the cylinder is too small. For example, this is just totally a random example. Let's just pretend that initially I had 20 milliliters of water, and I add in a piece of metal that's supposed to be 5 milliliters. And so the final volume then should be 25. But if some of that 5 milliliters of water splashes out, it might show that the final volume reading is only 24 milliliters. Well, that's not accurate. That other milliliter is now off on my table or something. And so it's going to seem as though the volume of the object is too small. And then when I plug that into my density calculation, if my volume in the denominator is too small, it's going to seem as though my density is too high. So for the 1 point, we have to say too high and have a good explanation. You don't have to draw pictures, but we have to have a valid explanation. On AP free response, it's pretty similar. If you don't have a valid explanation, you get nothing. First you have to say the density is too high. If you say it's too low, you also get nothing. But here it's like a 50-50 guess. So some people will say well, what if I just say too high? Do I get partial credit? But no, because you could have just guessed, and it really shows no understanding of the concepts. And then finally, question 4. Another student reported the final volume of the graduated cylinder plus the metal cylinder, the metal piece, to be just 21.5 instead of 21.50. So here's kind of what I was mentioning before. Would that measurement of 21.5 milliliters be correct? And obviously then we'd say no, because if we're using this same graduated cylinder that has markings every 10th of a milliliter, if I think it's right on the line, I should still estimate the 0. And if I just leave a measurement of 21.5 milliliters, then that 0.5 is my uncertainty. So really then that would indicate that my graduated cylinder only had markings every milliliter, but that's not the case here, that it should have markings every 10th, so that then the estimate would have been the hundredths, which you can always estimate 0 if you think it's right on the line.